welcome Dr. Charlie Su.
Hello, everyone. So another AI subject. So today I'm going to talk about RISC-V solution for AI and machine learning, not just for the data center, but also for the edge and endpoint. So like Lou just showed the number. So the market research data for RISC-V by SHD group. So I think we focus on the ratio. So this is about RISC-V SoC market. So it grew almost 3x last year. And for the next coming 6 years, going to go another 16x with a CAGR for the almost 50%. So among them, I want to share with you, they also point out for last year, and this had over 30% of the market share of RISC-V IP shipment. So we had customers ship into a mobile space, MPU, MCU, AIoT, and all kinds of flash storage, 5G networking, and also auto-grade SoC with our certified automotive processors. And last but the most is large-scale AI machine learning, where we have the largest customer working on this area, which we're going to talk into more detail. So first, Meta Training and Inference Accelerator, MTIA first generation. They revealed it last year in an academic conference, where the two important processors in the PE subsystem using our early generation of NX27 vector processor, use that to control their AI subsystem with all kind of accelerator. So the important thing we offer is that automated custom extension allow them to create new interfaces, new register, and wrap that with new instruction. So their AI compiler can directly control through our processor to their hardware accelerator. And all this, also we generate automatic file so to enable their LLVM compiler. So this year, just about a month ago in Hardchip, they revealed a new generation, MTIA, and it's already served in their production on the Facebook, Instagram, and so on. So you look at two generations of block diagram, it look alike, right? Even though they didn't say which RISC-V code they are using. And in addition to the Meta, so RISC-V, through us, we enable a lot of innovation on large scale AI ML. They based on our vector processor, NX27V and X45 MPV, and also our auto-order processor, X65, and also simpler, smaller processor, X25. But they all come with this automated custom extension, allow them to add instruction to connect to their hardware accelerator. So here's a couple examples. So we have customer working on their AI accelerator using SRAM-based computing memory, like Axera in Europe, and Ren AI and Tetraman in the US, and also Homo in China. And we have customers using AI accelerator, using photonic to implement their AI accelerator, like Intelligence. Also, AI accelerator for the cloud service, like Sapien. Recently, they merged with another Korean company. Both are Korean companies, but they merged together, getting bigger. And we also have customers using AI accelerator for others. So based on that, we know that even though most of the spotlight is in AI on the cloud, but edge AI actually is bigger. So to give a couple examples for the edge AI ML application, or so-called on-device intelligence. So they are intelligence edge server with specific domain knowledge, like legal, medical, even the enterprise HR information. Or smart factory, healthcare, transportation, where AI can use to monitor or doing a predictive maintenance. Or networking system for the enhancement of performance, security, and traffic management. And also ADAS, self-driving vehicles, surveillance, robots, and so on. So there's plenty of opportunity there. So what does RISC-V have to offer for AI ML application? So first, in AI ML application, there's a lot of computation, so we want to accelerate, so it can be done in the real speed. The major one is metric multiplication. So in CNN, it takes about 80% of computation, but even in the latest popular transformer and LLM, it takes about 50%, so it's a big chunk we want to accelerate. So there are hardwire solution, or kind of hardwire solution. They're probably most efficient and powerful, but it is metric. You turn that into the instruction form to become most flexible, so easier for software, especially AI compiler, to control it. So for that, RISC-V had two task groups working on two different kinds of vector instruction. One is integrated metric extension, which leverage existing vector infrastructure, and also attached metric extension, which is kind of independent of the core. It's a little bit more like hardware solution. You can sit on the bus. So the next one is there's a bunch of nonlinear activation function keep coming as the algorithm, new algorithm come up, like softmax, sigmoid, Jelu, and so on. So those are most suitable for custom instruction, because I doubt any architecture would make that become a standard instruction. And it's happened to come into the RISC-V's strengths, where we have custom extension, extensibility, allow people to bring their innovation there. And last but not least, so remaining there's still a lot of remaining parallelism with smaller, less structural. So for that, RISC-V has a full blown of basic computation, but you can have very wide width, vector extension. And also for smaller parallelism in the endpoint, we have SIMD, DSP, P extension. So they are there to catch all and provide future proof. So this is kind of technology-wise. But also very important, I think the previous speaker also mentioned that ecosystem for AI framework and also application framework is very important. RISC-V as a standard, it basically attracts fast-growing open source and also commercial support there. And the RISC-V itself, we provide a profile like RVA 2022, now 23 is almost there, even though this is 2024 already. But that profile basically provide, reduce the variation in terms of different RISC-V extension, and also consolidate the ecosystem efforts. So here I want to introduce you Endless Air, or Endless AI runs everywhere, which is the end-to-end AI ML solution, which Endless provide. So on the top, you can take an AI or NN model and all the way down to SQ on your hardware. So we're going to talk about the detail later in later slides. But in addition to those, we also, whole solution will also provide generic tool there, like our NSI pipeline optimizer viewer, and also ACE Copilot tool. So first, let's look at Endless vector processor family. So X25V100 and X27V is the first generation vector processor used by Meta. So it based on simple 5-stage single issue pipeline, and can have a vector width and also the computation produced by one instruction up to 512 bits. So and new generation, the X45 MPV is our hardest selling vector processor today. It's based on 5-stage dual issue with 8 core per cluster. It provides high-speed vector, local memory, and also in addition to our popular ACE for custom extension, it actually provides ACE for RVV, which is allow custom to adding the custom vector instruction to optimize their workload. And we also support the full arithmetic instruction for bflow 16, and has vector length and vector computation, or D-length, up to 1024 bits. And we are working on next generation already. So it's X46 MPV, which we're working on the integrated metric extension, which is one of the standard that RISC-V is working on. And we extend the 8 core per cluster to 16 core per cluster, and also private L1, L2 cache. And ACE for RVV going to continue to enhance. At the same time, our vector widths go to 2K bits. And there are 47 MPV. So we're going to provide more feature like CHI-based cluster coherency, latest RVA standard, and more floating-point format like FP8, FP4, and so on. So I want to give an example of how customers use our ACE with automated extension. And this presentation is done by RAN AI in Andes RISC-V Con in San Jose the past June. So they basically using the ACE RVB to basically generate another function unit inside our vector processor pipeline. So it's basically very natural. They don't need to know too much about our vector processor. They just focus on their computation. So they can. So what they do is they in the talk they present how they do sigmoid instruction, the vector instruction. And in their SoC, they actually also adding softmax, CELU, and other ACE instruction to help speed up their workload. And what's important in our ACE framework is that with our compiler tool, RTL, compiler, and system simulator would automatically update it depending on what kind of update they made to their instruction definition. And next, I want to talk about this application processor family, because when you run AI workload, other than just computation, there's a lot of application level control you need to do. So this first is our X60 series. So X65 is our current product, which is based on RVA 22 plus. It's 13 stage order execution, multi-core cache coherency, Linux capable up to 8 core per cluster. And we already have customers using it. And we are working on X66, which is 20% higher performance and going to support RVA 23. And this is a superset of so-called Android base, which including vector crypto, hypervisor, and so on. And one thing that we particularly added, most important for X66, is the vector processor, which has 2 pipelines and they share with a 14-point. You can execute any 2 ALU vector instruction and 2 load or 2 store. So we're going to have provide plenty of performance boost there. And beyond that, we're already looking into S67, which is going to bring another like 10% performance there and going to catch the latest RISC-V standard there. And we reserve a spot called X63, which is a power optimized version because some customers may not need that much high performance of 4-way superscalar, and they probably need 3-way or 2-way, but power is more important there. So it's kind of custom-driven spot. And in parallel, we have another project called Cusco, which is development in parallel by a different team. So it's a 14-stage, 6-way or 8-way auto-order processor with our patented time-based scheduling. The feature-wise is very similar, but microarchitecture is very different. So the performance can go up to another like 50% to 2x of our 67 series. Okay, so we talk about different our application processor core or vector processor core, and customers may have their own hardware accelerator. So there are a couple of different ways to put together compute subsystem in AI SoC, depending on where your trade-off point. For example, you can have application core with small vector, and you have a large vector core, and with a long vector VLAN, and you have our hardware accelerator for matrix multiplication. And it's up to customer. You can use ACE to kind of instructionalize those computation. And you can also have the more and bigger application processor core with wider vector and get rid of that vector. So that's another option, but your performance may drop a little bit because the SoC one, the left one, is very fully optimized for particular workload. And going forward, since now a processor with the metric instruction, you can include vector computation. So you may want to, in some application, you may want to get rid of the hardware accelerator altogether. So first you may suck into the vector core, so that one scenario, or you can suck that in all the way into just one type of application processor, which with shootable VLAN and with metric multiplication, and also ACE-RVB to adding the instruction for the nonlinear function, for example. And different form has different implication in terms of the attribute on the left. So, for example, you have just one application processor. It provides probably the best programmability, because the general purpose is just one kind of processor you need to program. But your performance may be lower because you don't fit everything. But the other extreme is you have different hardware and you can fit your application very tightly. But this is kind of the option or the choice of the SoC design. So we provide all the options for customers to do. So, and this is software. So it's on top, basically we can take the model and go through our NM-Pilot to do the graph level optimization, such as pruning and quantization, and they do the backend optimization there. And bunch there. And within it, there's AI compiler, there's library, and so on. So for example, in the AI compiler trend, there's LVM, which can auto-vectorize the IR generated by ERIS or TVM. So those are open source compiler. And ERIS itself can take microkernel optimized with RVV instruction or even ACE-RVV instruction. So this is optimization can be done by per processor. So we do a lot of work here on the microkernel. And also, and this invented auto ERI, which is basically the flow to find the better tiling efficiently instead of user can try it by hand. And with our experiment, you can achieve over 2x performance improvement over just using plain ERI. Here we have example done by vector length of 512 bits and 1024 bits, and using 3 different AI models. And in the library part, so we have NN library, which is proprietary by NDIS, mostly focused on MCU part. And you can take the kind the used by the template generated by the NM-Pilot. So it's over 200 functions there, so it's quite coverage. But we continue to evolve to take the latest the models to support different operator, and they also back up by more general purpose vector and also DSP library, which has over almost around the 400 of them. And then the open source based NN XNN pack. It has about 200 high-level functions and support PyTorch and TensorFlow Lite. There's a lot of functions which need to optimize and can be optimized using the standard RISC-V RVV instruction. It's just that there's more function that we can continue to optimize as a RISC-V community. So the key takeaway today is that RISC-V has been used in AI, machine learning, basically from cloud to the edge. And RISC-V advantage is in the mature and scalable vector instruction and upcoming metric extension. And with extensibility, RISC-V can allow customers to add in custom instruction. And this not only just offer the signal interface for customers to do the work. We automate basically everything you need to do related to processor, other than the function yourself that you need to decide. And RISC-V, the open standard, basically enable fast-growing software ecosystem. I think the RISC-V profile will further consolidate the effort and speed and make RISC-V run even faster. So, and this offer for machine learning, I think we have a couple things. The end-to-end software tool with NDIS optimization, and also in the efficient vector core in our 40 series processor, and also powerful Linux core 60 series and Cusco series. So if those are not what you need, NDIS has over 30 RISC-V core to help customer to complete the last piece of puzzle. So to just give an example, We just announced a PR probably about 30 minutes ago with Rivers. So the title is that Rivers select this NX45 for control function in upcoming high-performance RISC-V SoC. And the subtitle is NX45 become the only RISC-V core to pass Rivers' rigorous verification process after extensive evaluation of leading RISC-V cores. So thanks Rivers for selecting this, and wish you guys good success. Thank you.